Okay, so welcome to this example, and I would like to begin by apologising for my rough diagram. So we have a particle which we're told is static, i.e. the forces resolved vertically and horizontally are always going to be equal to 0, right? We've been told two of the forces, we have 12 and 10, and obviously we have the directions included with that. We then have this third force, which has two unknowns. It has an unknown angle and it has an unknown magnitude. Now, just a quick basically a quick point I would say is that because we have two directions of resolution, vertical and horizontal, it means that we will have basically two equations, which we saw in the introduction, which means that we can solve simultaneous equations in two unknowns. In other words, what I'm trying to say is for this kind of question you can have up to two unknown values. Okay, in this case it's the angle and the force, but sometimes it could be any one. It could be the angle or the magnitude of either one of these forces as well. Okay, so anyway, not to get too bogged down with that, let's jump straight into this. So I'm going to start by resolving horizontally to begin with. So if we're resolving horizontally, then this force has nothing to do with it, okay, because this is a vertical force only. It has no horizontal component. So we have in the positive direction 12 newtons. Take away F cos theta, and that's equal to 0. Okay, that's our first equation. The second equation we're going to resolve vertically. Now, because it's vertical, it's now this force that has absolutely no input whatsoever. Okay, so we'll have F sine theta minus 10 is equal to 0. So we've got essentially simultaneous equations here. Now I'm going to rearrange them both a little bit. I'm going to start by bringing this F cos theta across. So I get from equation 1, equation 2, so from equation 1 I get equation 3. Move the F cos theta across, so F cos theta is equal to 12. And equation 4, which I'm actually going to put here, just to mess up people's sense of order, will be, if I move that 10 across, F sine theta is equal to 10. Now the reason why I've put these in a strange order is because I'm going to do a division now. Okay, I'm going to divide basically the top by the bottom, so 4 by 3. So when I do that, I get F sine theta divided by F cos theta, which allows me to cancel out the F's. And that will leave sine theta over cos theta, which is tan theta, is equal to 10 over 12. Okay, so if I just grab my calculator, I can calculate what theta must actually be. So let's just make sure we're on the correct thing. I want this in degrees. So arctan of 10 divided by 12. Okay, so I've got that theta must be 40 degrees, and I've rounded to the nearest whole number. Okay. Well, now that I've got what theta is, I can actually choose any one of the equations I kind of want to calculate what F would be. And I'm going to choose equation 4. Okay, so F sine 40, now it's actually 39.81, and I'm going to carry my answer across, okay, is equal to 10. So if I do 10 divided by sine 40, I get that F must be 15.62 newtons, and I've gone to 2 decimal places. And then that's it.